Extrasolar planets. These are planets outside of our solar system. They orbit a star that is not our sun, so some other star. We have found 800 planets, and as I'm saying this, I know that number is wrong. Because they've found another 7 planets that are 40 light years away. They have found yet another planet, I believe it's 450 light years away. And it just keeps growing. They've found 600 stars and a total so far of 2,300 possible planets. So they've got things that they're looking at, 2,300 of them that could be possible planets. Right? Better technology, better data, more discoveries. So as I'm telling you this, I know those numbers are outdated. Now, planets outside our solar system are too far away to be viewed, right? Because planets don't have their own light like stars do. So how do we find out that they're there? Well, a couple different ways. We can guess that they're there by the gravitational force, right? Kind of like we guessed that Neptune was there because it was pulling on Uranus. Oh wait, we haven't actually talked about that yet. We'll get to that one, but gravitational force can be one way. We can see star wobble. So our star, our sun, isn't always in the same spot. It actually does a little tiny orbit. Just a little tiny orbit. And why is that? Because all of the planets are pulling on it. And so it's moving back and forth. And so the bigger the planet, the bigger the wobble. Right? So if we see a star moving, there has to be something pulling on it. The more it moves, the bigger the planet. Upsilon Andromeda? Not sure. Andromedae? I don't know. Anyways, there's this star that has 3 planets that we know of that are at least as big as Jupiter. And then there's star 51 Pegasi, very similar to our sun, and it has a planet on it that's half the size of Jupiter.
Star. Officially called 51 Pegasi b, the planet is nicknamed Bellerophon in honor of the Greek hero who tamed the winged horse Pegasus. It is a planet that breaks all the rules. Bellerophon roasts in the blazing starlight at temperatures of roughly 1,800 degrees Fahrenheit, almost 1,000 degrees Celsius. It is nearly 150 times more massive than Earth, and is a gas giant like Jupiter.
A gas giant is a planet made mostly of hydrogen and helium. Only the outer layers are gas, but inside, hydrogen and helium is compressed to huge pressures. It doesn't resemble a gas at all.
Unlike anything found in our solar system, this is an entirely new class of planet, what scientists call a hot Jupiter.
If you go to Hawaii and see the lava flow there, that's how hot a hot Jupiter is. It's very, very hot.
The Earth is a comfortable 93 million miles, or 150 million kilometers away from the Sun.
These hot Jupiters are roughly 100 times closer, and so the amount of sunlight that they give is 10,000 times larger.
If this represents a star, and this a hot Jupiter is 3 to 4 stellar diameters away from the star. So that would be 1, 2, 3. This is how close a hot Jupiter would be to its star. Hot Jupiters are tidally locked. They present the same face to the star at all times, just like the moon does to Earth.
It's going to be permanent daylight on one side and permanent nighttime on the back. If I were stuck on a hot Jupiter, I'd want to be on the back side. and hope that some of the heat from the front side facing the star would make its way around the back.
The variations in temperature make Bellerophon's atmosphere extremely windy. As the air is cooked by the star, it rises. Cooler air rushes downward to replace it, just as it does on Earth.
So that was a video about an extrasolar planet. And there's lots of those. Like I said, they recently found a set of 7. And then they've just found another one, a hot Jupiter. Now, what am I talking about with hot Jupiters, cold Jupiters, super Earths, Earths? What does all that mean? That's where this chart comes into play. Okay, so if you look at the chart, you can see there's Jupiters, Neptunes, super Earths, Earths. And most of the dots are in the Jupiters, some in the Neptunes and super Earths, like a couple in the Earth section, right? That's because the bigger the planet, the bigger the wobble, so it's actually easier to find bigger planets. That makes sense. So we found a lot more Jupiters right away than we have the other planets. Now what's this hot and cold? Well, hot means you're close to the sun. You're 0.1 AU away from the sun. Now remember, Earth is 1 AU, so it's 90% closer to the sun than we are, at least. So Earth would technically be called a cold Earth. And then we have super Earths. Super Earths are 2 to 10 times the size of Earth. Okay, that's all that means. We know of 5 exo-Earths. Okay, so the media likes to take this and run with it. Oh, there's 5 exo-Earths. That means there's 5 extrasolar Earths out there. There's 5 Earths around a different sun, right? And so they're all picturing and telling us to picture an Earth. You have blue oceans, green lands, rainforests, trees, animals, people even. You know, somewhere we could go and live, right? No. All an extra Earth means, or an exo-Earth, is that it's orbiting a different star and it's the size of Earth. That's it. Technically, Venus would fall into that category. Nobody wants to go live on Venus. And Mars would fall into that category. Nobody seems to want to go live on Mars. I mean, we're trying to, but we have to make some adjustments. We can't just drop ourselves there and woohoo, we're on Earth, right? So don't get too excited when they say, we found an Earth. Okay, so this is just emphasizing the hot and cold. Hot, you're close to the sun. Cold, you're further away from the sun, right? Closer you are to the sun, literally the hotter you are going to be.